Okay. Now I'm going to show you one more type of pattern, which we can, let's name it as a rectangular pattern or square pattern, whatever you may call it. Now this will determine the remaining patterns which we are going to learn. Comparatively it's complex, but it isn't that complex that you won't be able to understand. It's pretty simple. Let me take it this way. 1, 2, 3, 4, 5. In the second row, 2, 3, 4, 5. And then we have a rotation. Again, it begins from 1, 3. It's divided into two halves. But this is one pattern which we had learned earlier, and this is one pattern which we had learned earlier. So what we are going to do is, we'll have one loop. Of course, this loop is for each line. And inside this one loop, we'll have one inner loop which is going to determine this particular, the left side of the pattern, the first one. Whichever is the first pattern, the first inner loop is going to determine that. And the second one will be represented by the second innermost loop. This is how it is going to work. So this is, in the nutshell, this is how we are going to do. We'll have one main loop and then two inner loops for the two sides of the pattern. Now first of all, let me tell you that the outer loop which you are going to take may be any value from 1 to 5 or 5 to 1. Preferably, you can take that particular set of numbers which is complete by nature. Like here, you see this is complete by nature, this particular side 1, 2, 3, 4, 5. This started from 1, so therefore it went till 5. You can also take this one in case these are different set of numbers. Here it is constant, we have no other way, we cannot take this. So it is preferable to take one side which is complete in the sense that all the numbers from 1 to 5 are present because there are 5 rows. So we'll take 1 to 5. Although we could have gone for 5 to 1 even. Now we'll start with the second half. Now this is quite critical. We need to understand this very well. Now here, since the value of I ranges from 1 to 5, so the value of I will be 1, 2, 3, 4 and 5. Now for the first half. For the first half, when the value of I is 1, the innermost loop runs from, this is the first inner loop. And here we are going to write the second inner loop. Okay, let me differentiate. Put a straight line to differentiate. Okay, when the value of I is 1, look at the first line of the first pattern. It runs from 1 to 5. So let me write that 1 to 5. And when the value of I is 1, nothing of the second half, that is second pattern, gets printed in the first line. So we'll just put a cross. Let's not bag our brain over there. Okay, next time when the value of I is 2, this half runs from 2 to 5. So we can tell 2 to 5. However, for the second half, only 1 gets printed. So this loop should run from 1 to 1 or simply 1. Okay, when the value of I is 3, when the value of I is 3, it runs from 3 to 5. So 3 to 5. Whereas out here, 1 to 2. So we can tell 1 to 2. When I is 4, 4 to 5. So 4 to 5. And this one, 1 to 3. So 1 to 3. And ultimately when the value of I is 5, so it is only 5. So we can tell 5 to 5. And this one, 1 to 4. Now looking at this, so that means this is one inner loop and this is another inner loop. So here, J, look at this. When the value of I is 1, it starts from 1 to 5. When it is 2, it starts from 2 to 5. When I is 3, 3 to 5, 4, 4 to 5, 5, 5 to 5. So I can tell it always starts from I, because whatever is the value of I, this inner loop also begins from I till 5. So J will start from I till 5. J plus plus. Now let me print the value of J. Okay, for the inner loop. This one, okay, we can reuse the variable j, because once a loop has ended, we can reuse a variable. So now, when I is 1, nothing, we won't think about it. When the value of I is 2, it runs from 1 to 1. When it is 3, 1 to 2, 4, 1 to 3, 5, 1 to 4. If you notice carefully, it always begins from 1. However, it always ends one number less than the value of I. You see, when the value of I is 3, it runs till 2. When it is 4, it runs till 3. So 5, it runs till 4. So a number less than, that means it runs till I minus 1. So that's it. It always begins from 1 but ends at I minus 1. So that's the trick. So j will start from 1 but ends at I minus 1. That's it. And here we can display the value of j. At last, we'll go to the next line. Okay, now since we are done with the program, let's see how this is working. Initially, the value of I is 1. So when I is 1, the j loop runs from 1 to 5. And therefore, all values from 1 to 5 gets printed. So 1, 2, 3, 4, 5. And now it comes over here. J is 1. J less than equal to, since the value of I is 1, 1 minus 1 is 0. Now, since j is 1, 1 is not less than 0. So it never enters the loop for the first case. First case means when the I iterates for the first time. So it directly comes over here, system.out.println. So it goes to the next line. Next line, the value of I is 2. So this loop runs from 2 till 5. So 2, 3, 4, 5. And look at this particular hub. 1 to 2 minus 1. 1 to 1. 1 to 1. So it's going to print just 1. Next time the value of I is 3. So it runs from 3 to 5. So therefore 3, 4, 5. And this one from 1 to 3 minus 1. That means from 1 to 2. Next time the value of I is 4. So 4 to 5. So 4 and 5. And this one from 1 to 4 minus 1. That is 1 to 3. So 1, 2, 3. Ultimately, when the value of I is 5, so this is running from 5 to 5. And this is running from 1 to 5 minus 1. That is 1 to 4. So 1, 2, 3, 4. Okay. Now that you have understood, we'll try out a similar type of pattern. But this time, what I'm going to do is, the division which was diagonally from the right hand side, I'm going to make it from the left hand side and look at how we are going to do it. The technique involved is again the same. Initially, please write and do this particular program. Later on, you'll get a good, after you get a good amount of practice, you'll be able to just determine without even making such, workout. Let this be the pattern. 1, 2, 3, 4, 5. And we'll do it this way. 1, 2, 3, 4 and then 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, this is the half. You can see I'm aligning this side. Okay, what should be the outer loop? I said you can take either of them, either 1 to 5 or 5 to 1. We'll make a selection of that particular set of numbers which is complete by nature. So here ranging from 5 to 1. So we can go for 5 to 1 as the outer loop. This will only give us an advantage, nothing else. Okay. Now the value of I, the inner loop, the first inner loop, and then the second inner loop. We are going to determine that. Okay. You can see the value of I will be ranging from 5 to 1. So 5, 4, 3, 2, 1. Okay, when the value of I is 5, now do not make a mistake, this is our first half. So the first inner loop should be generating this particular pattern. So if you look at this carefully, there is no number of the first triangle getting printed. So we'll put a cross. As usual, we are not going to think about it. Whereas here, that is the second half of this particular pattern, 1 to 5 gets printed. So we can tell 1 to 5. When I is 4, just 5 gets printed. So we can tell 5 to 5. And for the second half, 1 to 4. You see how easy? When I is 3, 4 to 5. And this one 1 to 3. When I is 2, 3 to 5. This runs from 1 to 2. When I is 1, it runs from 2 to 5. And this is just 1, so 1 to 1. Now look at this. When I is 4, 4 to 5. When I is 3, 4. When I is 4, 5 to 5. When I is 3, 4 to 5. When I is 2, 3 to 5. When I is 1, 2 to 5. So we can tell whatever is the value of I, it starts from 1 more than that number till 5. You see, when it is 3, 4. When it is 2, 3. So I plus 1 to 5. So that should be the first inner loop. So J equal to I plus 1 till 5. Now we are going to look at the second half of the pattern. When I is 5, 1 to 5. When I is 4, 1 to 4. When I is 3, 1 to 3. You can see it always begins from 1, but it always ends, whatever is the value of I, with that. So when it is 5, it ends at 5. When I is 4, it ends at 4. That means we can tell it begins from 1 but ends at I. And here we'll get back to the next line. That's it. You see how easy it is to determine this kind of pattern. Okay, now we are going to try one more type of pattern. Not type of pattern, similar type of pattern, but you'll find it quite peculiar. 5, 4, 3, 2, 1. 4, 3, 2, 1, 5. Okay, let me put it 1, 3, 2, 1, and then again 1, 2, 2, 1, 1, 2, 3, 1, 1, 2, 3, 4. So here if we divide it, this is how we divide it. So we are going to determine the outer loop. We can go for 5 to 1 till 1 I minus minus. So when the value of I is 5, the loop runs from the first half, it starts from 5 to 1. 5 to 1, and no numbers of the second half gets printed, so the second half is nothing, so we put a cross. When I is 4, 4 to 1, and here only 1 gets printed, so 1 to 1. So when I is 3, 3 to 1, and just 1 and 2 gets printed, so 1 to 2. When I is 2, 2 to 1, and this is 1 to 3. And when I is 1, just 1, so 1 to 1, and this is 1 to 4. Okay. Now if you go for the program, the first half, now let's see what is happening. When I is 5, 5 to 1, 4, 4 to 1, 3, 3 to 1, 2, 2 to 1, 1, 1 to 1. This is quite similar. Whatever is the value of I, it starts from there and ends at 1. When I is 4, 4 to 1. When I is 3, 3 to 1. So we can tell J starts from I till 1. Okay, now talking about the second half. When the value of I is 5, nothing gets printed as usual. When I is 4, 1 to 1, 3, 1 to 2, 2, 1 to 3, 1, 1 to 4. Now, you cannot directly relate the value of I with this inner loop. You see, it looks quite different. 4, 1 to 1, 3, 1 to 2. It's neither ending or beginning at I. Neither one less or one more than I. So here, if you notice carefully, this part is constant. You see, this is quite easy. Always begins from 1. So we can tell J always begins from 1. So at least we can minimize our requirement. Now you see, when I is 4, it ends at 1. When I is 3, it ends at 2. When I is 2, it ends at 3. When I is 1, it ends at 4. Now if you notice this carefully, there is a sequence. Now, if you add this up, 4 plus 1, we get 5, 3 plus 2, 5, 2 plus 3, 5, 1 plus 4, 5. So it's always 5, it's constant. So I can tell the second J loop always ends at, since the summation was 5, so I can tell it ends at 5 minus 1. 5 minus I. Now look at this carefully. When I is 4, 5 minus 4, how much do we have? 1. When I is 3, 5 minus 3 is 2, so here we have 2. When I is 2, 5 minus 2 is 3, so here it is 3. When I is 1, 5 minus 1 is 4, so here it is 4. So it ends at 5 minus 5. So here, please remember something, if we do not get a relationship directly with I, that is either I ends at I or begins from I, or just one less than I or one more than I at the beginning or at the end, in that case you will find that the summation of one of the part, that is the starting or ending part, will always be equal to a constant value, the summation. So that summation, that constant value minus I is going to give you that value. It's that simple. Okay, now instead of giving a particular half, they might be not giving one of the half. So in that case, what it means is they might give you a pattern which is right aligned. I'll tell you what happens. Suppose they give you 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Now, here, once again, we can use the same technique what we had learned earlier. But this time, this half, we can imagine it to be a pattern of spaces. Even a space is a character in Java. So here you can imagine there are 4 spaces. So each of this dash indicates a space. And here we have 3 spaces. Here we have 2 spaces. Here we have a single space and then no space at all. So here we have a similar type of pattern which we had learned earlier. So now, if we take this, okay, we'll go for 1 to 5 because you can see over here, this is complete in nature. So 1, I less than equal to 5, I plus plus, this is more preferable. Okay. Now thinking about each one of this half, the value of I have taken from 1 to 5. So 1, 2, 3, 4 and 5. Now the first half and the second half. When the value of I is 1, you can see I am printing 4 spaces. So 1 to 4. You can tell that. When I is 2, 3 spaces. So 1 to 3. When I is 3, 2 spaces. So 1 to 2. When I is 4, I am printing 1 space. So 1 to 1. And when the value of I is 5, nothing. So we put a cross. Now for the second half, when I is 1, 1 to 1. When I is 2, 1 to 2. When the value of I is 3, 1 to 3. When I is 4, 1 to 4. This one is simple. When the value of I is 5, 1 to 5. Now look at this. Once again, this and this, we hardly have a relationship directly with I. It's neither beginning or ending with I, or one less than or one more than I. So naturally, we'll go for the summation technique. Here it is always fixed, starting from 1. So naturally, j will be 1, no doubt regarding that. So for j equal to 1. Now look at this. 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. So we have a constant value. So we can tell that it always ends at 5 minus I. You see 5 minus 1, 4, 5 minus 2, 3, 5 minus 3, 2, 5 minus 4, 1. So j equal to 1, j less than equal to 5 minus I. That's it. Now this one, please keep a note of it. System.out.print. We are going to print a blank space. Now we are going to think about the second half. When the value of I is 1, it starts from 1, ends at 1. When I is 2, 1 to 2. When I is 3, 1 to 3. This is quite simple. It starts from 1 but ends at I. This is quite simple. So we can go this way for j equals to 1, j less than equals to I, j plus plus. So print j, and we have system.out.println. Okay, let me take a pyramid pattern of this shape and this value 1, 2, 1, 1, 2, 3, 2, 1, 1, 2, 3, 4, 3, 2, 1, 1, 2, 3, 4, 5, 4, 3, 2, 1. Okay, now if you look at this, basically this consists of 3 patterns. You can imagine this. This is one pattern consisting of space. This is one pattern consisting of this set of numbers. And this is another pattern. So we have 3 patterns. So once again, what we are going to do, we are going to have one big loop, and inside that, this loop determining the first half, this loop determining the second half, another loop this time determining the third half. Now you see, it isn't that difficult. The outer loop will be chosen that set of number which is complete by nature. As usual, the same rule holds true even for pyramid patterns. So starting from 1 to 5. So we can go for the outer loop as 1 till 5. Now, let me draw the spaces to make things easier. Here 1, 2, 3, 4. 4 spaces. Here 3 space, here 2 space, here 1 space. Okay. So the value of I has been assumed to be from 1 to 5. So 1, 2, 3, 4 and 5. And this will be the first inner loop. And here I am going to write the second inner loop. And here I am going to write the third inner loop. Okay. Now when the value of I is 1, how many spaces? 4 spaces. So we'll make the inner loop iterate from 1 to 4. When I is 2, 3, so 1 to 3. When I is 3, 2 spaces, so 1 to 2. When I is 4, 1 space, 1 to 1. When I is 5, nothing, so we put a cross. Now going to the second half. When I is 1, I am printing just 1, so we'll write 1 to 1. When I is 2, 1 to 2, so 1 to 2. When I is 3, running from 1 till 3, so 1 to 3. When I is 4, 1 to 4, so 1 to 4. When I is 5, 1 to 5, so 1 to 5. Now let's go to the third half. When I is 1, nothing out here gets printed, so we'll put a cross. When I is 2, we just print 1, so we can tell it runs from 1 to 1. When I is 3, it runs from 3 to 1. When I is 3, it runs from, no, this is I is, here the value of I is 1, here the value of I is 2, here the value of I is 3. You need to be careful, it runs from 2 to 1. So 2 to 1. When I is 4, it runs from 3 to 1. When I is 5, it runs from 4 to 1. Okay. Now writing the first inner loop. 4. You can see there is it starts from 1, so at least that part we can minimize the complexity. So here it starts from 1. Now, no relationship with I directly, not directly, neither minus 1 plus 1. So the technique is we are going to sum. So 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. So naturally, this loop runs from 1 till 5 minus I. 5 minus 1 is 4, 5 minus 2 is 3, 5 minus 5 is 0, 5 minus 4 is 1. So we can tell it ends at 5 minus I. So j less than equal to 5 minus I. And here we can print the spaces. Print, look at this, I'm printing spaces because the first half is full of space. Now going for the second half. When I is 1, 1 to 1, I is 2, 1 to 2. I think you can guess it. When I is 3, 1 to 3. So it runs from 1 till I. So we can reuse the j loop since it has ended. Less than equal to I, j plus plus. Here we can print the value of j. Now the third one. When I is 1, nothing is to be printed. When I is 2, 1 to 2. When I is 3, 2 to 1. I believe you can guess now. Whatever is the value of I, it always starts from 1 less than that. You can notice when it is 4, 4 minus 1 is 3. When it is 3, 3 minus 1 is 2. When it is 2, 2 minus 1 is 1. So we can tell it starts from I minus 1 and ends at 1. That's fixed. So for j equals to I minus 1 till greater than equal to 1, j minus minus because it's decreasing, and here we can print it. System.out.print j followed by system.out.println. Long method, but it is effective. Thank you, friends. I believe you could understand how to make such patterns. Isn't that difficult at all? Once you start understanding and the way I have taught you, once you practice this, you won't even need to think the way I have taught you. You can simply do it by yourself in any method possible.